We're going to start by defining what a statistical variable is. Now, when you're collecting data, the data could be both quantitative or qualitative. Now, a qualitative data can be categorized, like, for example, when we're collecting data about eye color, hair color, or even car types. But quantitative data takes numerical values, like, for example, when we're speaking of number of children in families or heights of students. And when we're speaking of quantitative data, it can actually be represented by a variable that could be both discrete or continuous. A discrete variable takes exact numerical values that can be counted, like, for example, the number of children in families. However, continuous variables do take numerical values that can be measured, like, for example, the height of students. And when we're collecting data, we often deal with sampling. Now, first of all, what is a population? A population is the set of objects that you're collecting data from, but it is often impossible to collect information or data from the entire population, given that usually populations are too large to collect data from or to survey. And this is why statisticians refer to sampling. Now, what is a sample? A sample is a subset of the population that gives information about the population as a whole, and is usually a good representative of the population. So what does that really mean? A good sample is a sample that has the same characteristic as the entire population, so that the data collected from the sample could be generalized to the entire population. And there are several sampling techniques that statisticians use. First of all, we're going to start with a simple random sampling that is often referred to as SRS. Now, in simple random sampling, each member of the population has an equal chance of being selected. And the sample is chosen by assigning a number to every member of the population and using a random number generator to randomly form the sample. Another technique is systematic sampling. In systematic sampling, the sample is chosen by listing the members of the population and choosing a random starting point and a fixed interval for selection. For example, if we have this population of 25 members, to form my sample, I decide on a random starting point. For example, I randomly decide to start with the 4th member. And then I decide on a fixed interval for selection, which means that, for example, I decide to choose the 6th member following the previous one. So starting from the 4th member and jumping by 6 members, I get to member 10. Then 6 members later, I get to member 16. And then jumping by 6 members again, I get to member 22. So consequently, out of this population of 25 members, I formed a sample of 4 members using systematic sampling. Now, another sampling technique is called a stratified sampling. Now, the sample is chosen by dividing the population into non-overlapping smaller groups called strata, which are formed based on the members' shared characteristics. Random samples are chosen from each strata and put together to form the complete sample. For example, given a high school with 900 students, now that's our total population. And suppose in this high school we have 3 year groups, year group 1, year group 2, and year group 3. These year groups do in fact form our strata. So in order to form our sample, what we in fact do is choose randomly a given number of students from each year group that we eventually put together to form our sample. For example, suppose we selected randomly 20 students from each year group, and then when we put them together, they do form a sample of 60 students. So that is how stratified sampling actually works. And another sampling technique is the quota sampling. Now, the quota sampling is chosen, the sample is chosen similarly to how stratified sampling works, but except that the sample size from each strata are taken in proportion to the size of the population. Now, what does that really mean? Going back to our example of our 900 students in a certain high school. Now, suppose that these 900 students are split into 60% females and 40% males. Then, given our three strata that are formed by the 3 year groups available at this high school, and the 20 students that we select randomly from each strata, but we eventually make sure that each of the 20 students have or include 60% females and 40% males, so that when we put the sample of 60 students together, the sample does also include 60% females and 40% males, just like the given population. And one last sampling technique that we're going to discuss is called the convenience sampling. Now, this is one of the easiest sampling methods to choose, but it's a less reliable one because the sample is chosen by selecting the members of the population that are easily accessible. For example, a student that wishes to form a sample to survey, he could perhaps go for his classmates or the people that are related to him, because these are the people that he can access easily. So that is what convenience sampling is. But when we're dealing with sampling, we could be dealing with bias. Now, bias in sampling is when incorrect statistical information is concluded, which could give a skewed interpretation of the general population, which means that we could have collected inaccurate information that does not represent the entire population. And the sources of bias could be excluded members of the population. For example, surveying people online may exclude those with no access to the internet and could potentially affect the results of the survey. Or it could be the non-response, where surveying university teachers, for example, where only the youngest teachers respond and the older ones don't. So in that case, we would have bias in our results. And it could be a non-clear questionnaire. For example, questionnaire questions that may be unclear could lead to misleading results because of the fact that maybe the participants or the people taking the survey did not really understand well the questions, so that could lead to misleading information. And finally, the last source of bias that we're going to be discussing here is untruthful answers, because sometimes people or participants could be intimidated to give truthful answers. So in that case, you will be dealing with bias as well. And now, in addition to bias and sampling, we could have outliers that could eventually affect the interpretation of our survey results or our data collection results. Now, an outlier is a data point that differs significantly from other observations, as you can actually see in that chart that we have here. Now, an outlier may be due to experimental error and could be excluded from the data set. So sometimes it might be needed to exclude outlier because they do make significant difference on the data collection results or interpretation. And in these cases, outliers could be excluded from the data set. Now, finally, when is your data considered to be reliable? Your data is considered to be reliable first if you repeat the data collection process and obtain similar findings, approximately of course, and if you have enough data to support your conclusion. Like the sample size is fair with respect to the size of the population. You did survey enough people. And the best maximum sample size is around 10% of the population, as long as it doesn't exceed 1,000 members. Now, if the 10% of the population contains more than 1,000 members, then 1,000 would be the maximum sample size.